In this lesson, we'll look at creating 2D toolpaths. After completing this lesson, you'll be able to create a facing toolpath and create a 2D adaptive toolpath. Let's carry on with the file from our previous example. In this case, we want to start to explore 2D operations. So we're going to use the 2D dropdown and select Face. Under the Tools section, we're going to go to our Samples library. We're going to change the operation type to be Facing. We then want to change the filter for the tool type to show Facing Tools, and this only leaves us with two available tools. We're going to use the 50mm face mill and say OK. Now this tool is quite large for this part, and we only really have the two small sections here that are going to be visible after the part's been faced, but it's still okay to play with this type of tool. Under the Stock Contour section, if you don't make any specific selections, it's going to use the entire profile of the stock. You can see the yellow preview on the screen, and we're going to leave it at that. We're going to use all the default heights, but notice that we're starting the retract plane 10mm above the retract height. The retract height is 5mm above the stock, and the feed height is 5mm above the top height. The top height is the stock top, and the bottom height is the model bottom. Under passes, notice that we're going to go both ways. We're going to use chip thinning, and this is going to keep the load on the tool consistent. This allows it to change its type of motion so that we're not instantly loading the part as we engage the side of the material, and then we reduce the chip load as we go along. This is great for not only cutting the part faster, but also reducing the wear on your tools. We're only cutting 1 millimeter off, so we don't need to handle multiple depths. But if you're cutting a lot of stock in this initial operation, with a roughing tool maybe you can use multiple depths. We're not going to leave any stock because we're taking 1 millimeter off the top and we're focusing on just this area, but you could also leave a small amount of stock to go back with a finishing tool. We're going to leave all of these stock lead in, lead out, and linking parameters and say OK. Because the tool is so large, it comes down, does one single pass, and goes back up, and it's all done. Let's take a look at some other 2D operations. Under the 2D dropdown, we have 2D adaptive clearing. We're going to use 2D adaptive clearing, and we're going to change the tool. We're going to go to Sample. We're going to change the operation type to Pocket. We're going to change the end mill type to only show a flat end mill. And we're going to take a look at what we have. We also want to make sure that we filter the tool by metric values. We're going to use a minimum of 8 millimeters, and we're going to use a maximum of 12 millimeters, and we're going to say OK. So if we take a look at the available sample metric aluminum tools, we have an 8, a 10, and a 12 millimeter available to us. We're going to go ahead and use the 10 millimeter, and we're going to say OK. Under the geometry section, I'm going to select the outside profile as well as this circle here. We're going to leave all of our default heights. We want to make sure that the selected contour is going to be the bottom height for our cutting operation. So that way we know that we're only going down to this face. And for our linking parameters, we're going to use full retraction. We're going to preserve rapid movements for our high feed rate. We're going to allow for rapid retract, which lets the tool pull away from the part fast. The maximum stay down is 50 millimeters, but since we're not jumping from pocket to pocket, that's not really a concern in this instance. We're going to leave the leads and transitions at 1 millimeter. We're going to do a 2-degree helical ramp, and we're only cutting down a few millimeters, so really in this case, it's not going to make too much of a difference. Then we're going to say OK. Now it's assuming that this is a pocket, and if we take a look at the operation, you can see it's only cutting the outside. Now if we edit this operation, we take a look at the geometry, you can see the arrow on the outside chain. We're going to go ahead and flip it so that it's cutting inside. You can see how the preview changes. We now have this blue region that's being cut. We can say OK, allow it to regenerate the toolpath, and take a look at the difference. Now the 2D adaptive toolpath uses these tool motions to minimize the tool burial. But in our case, it's actually an open pocket, and it doesn't understand that it can actually go over the edge. So let's edit and let's take a look at some of the options to see if we can allow it to go past those edges. Inside of our passes section, we have an option for slot clearing, but we're not dealing with a slot in this case. We can do multiple depths, and we can also leave stock. I'm going to turn off stock to leave and say OK. I'm going to regenerate it, and notice that the tool can go a little bit closer to the edge, but it's still not able to clear the material that we want. So let's go back in, let's edit this one more time, go to our geometry section, and let's deselect that outside contour and we'll trash it. So now you'll notice that the blue section is actually overlapping the edge because it's going all the way out to our stock. We're going to say OK, allow it to regenerate, and notice the difference in the tool motion. We still have an intelligent toolpath because it's minimizing the amount of tool burial. And you can tell if we look at it from the top that it's starting by staying mostly parallel, but you can see that it's actually changing the way that it's cutting based on the fact that it has to go around this boss in the center. So this tool motion is much more intelligent. It allows to go over the edge. We just need to make sure that we don't over-select geometry when we're trying some of these toolpaths. Let's make sure that we save our file so we can move on to the next step.